Aloha everyone, this is Philip with an eruption update. I'd like to add my voice to what Ikaika's and John Stallman have been doing a great job down in Puna. I've noticed some questions have come up, so let's see what I can do to address them. So let's see if I can figure out my rotation here. Just a minute. Let's see if this works. Nope, that doesn't work. Okay, just a second. Alright, thanks guys for just setting up here. Just a minute. Get this here sorted out. Alright. So, the first thing I'm going to do is switch my camera around here and show you guys the most recent map that's been put out. Here's a map from the USGS, put forth 11 a.m. on June 3rd. The main things that have happened as far as eruption in Leilani have been focusing to just a couple of events. Fissure number 8 over here in this area is still very much the dominant fissure. It's putting that big flow out towards the northeast, mostly going towards Kapoho. Here's the area of Kapoho. At last report, this flow is still advancing about a half-mile front, heading towards the ocean right here. It'll probably span this whole section on the coast right over here. Here's a report of where lava's come around the edge of Green Cone into Green Lake and fill the depression in there, in the cinder cone. There's a report also of fissure 16 being very weakly active right over here and putting out a new little flow that's kind of along the edge of the old flow down towards Kīlauea, but it's not getting very far. I wouldn't be concerned about this finger quite as much as what's happening way up here, and as well as what's happening in the area of fissure 8 over here. So right now we have these two dominant fissures. It's a big change from before when we had as many as 6 or 8 going off at the same time. So right now to 2, that's an interesting development. Oh, I got a big rainstorm coming through here, but hopefully you guys can still hear me. Okay. So there's also reports of fissure number 9 steaming quite a lot and more silver emissions coming out as well. So there's a big concern that the lava from fissure 8 is going to start emerging from fissure 9 as well in this area, and that could put out a big flow heading north through Leilani in this direction over here. All right, so this area is very much at risk, which is why it's under that mandatory evacuation notice. That's something to keep an eye on for the future. But for now, the main event is really up here in the east by where lava is going through vacation lands, Kapoho beach lots. Unfortunately, there are a lot of houses and farms right in the path of destruction. So it doesn't look like it's going to be that great a day for those people down there. Also, everyone in the area south of there has been cut off now, and there's talks about maybe about a dozen people who have been in there, stranded. The last I saw, there's Army helicopters coming in to evacuate those people, whoever needs to. So it's looking pretty good for those people, a lot better than it was just a few hours ago. Okay, so that's kind of the update down at the flow front right now. One thing to kind of address is people were talking about how the flow could have gotten into the Kapoho cone over that hill. It really didn't. It went around the bottom edge of the cone, the cinder cone. This cinder cone was actually built from a lot of steam explosions many hundred years ago, and it actually was open to the east side, so there's a gap on this side. That's why the flow has been able to flood into it from the east and has been filling up the crater inside. So that all makes sense. All the water has been evaporated from there. There was a huge steam cloud yesterday, which seems to have totally disappeared within a few hours. So that's the update from that area right there. So kind of to recap, we have basically one fissure that's the most active, fissure number 8 over here in this area right here. Fissure 16 is very weakly active, maybe dying off, at least for now. And 9 is the one that seems to be coming into play as a possible next eruption site. Okay, so hold on, let me see if I can address any of these questions. Okay, so I'm gonna keep gathering questions as you guys add them on, but I'm gonna try to save this for the end after I'm done with this initial section. Okay, so let's see. I'm gonna catch back up here. Okay, just a minute. All right. So the next thing I want to talk about is right now is basically the summit. There's been a big development at the summit. It keeps happening. The summit keeps collapsing. So here's a most recent animation released by the USGS showing a sequence. You can look right in here of what's been happening at the summit crater. So let me zoom out a little bit so you can see the dates up here on the map. Let's scroll down a little bit here. There we go. So there's the dates clipping at the top. We go from the beginning of May. You can see the crater is just growing and growing and growing. And the most recent frame shows the section right over here collapsing on the left side. Here it is, right there, right through there. So the size of that crater is getting to be bigger than the 24 collapse, which is a big, big area. Over 1,000 acres, they say, is the size of the new actual pit on the right side, but it looks like it might actually double itself within the next little while if that slump continues. One thing is that all that rock has kind of clogged that hole, so there's not a whole lot of space for it to go. It won't probably collapse all the way into that deep down lowest pit, but it is growing. One thing that's happened as well is that because of all that debris choking that hole, there's not as much steam coming out. There is still steam coming out, but not as much. There is potential for explosions as well, so it's going to keep exploding. Less steam coming out means it'll probably have a chance to explode more frequently. What I've heard is these explosions shouldn't be any bigger as far as how high they're going to reach and how far they're going to put ash. But locally, you could have some bigger blocks that are thrown out from this collapse pit up into the edges, an area right around here. This area is all closed, so no one's around there, so that's no big deal for anyone who's watching. But it's something we're keeping an eye on as well. Okay, so, all right, let me scroll back through the cameras. I'm doing this by myself today, so I gotta try to keep track on what's going on. Okay, is there still lava in the volcano? Yes, the whole thing is full of lava. We look at the caldera, which is this outermost crack, the biggest crater on top of the volcano. It's something like 2 by 3 miles, something like that, as more or less the size of the magma chamber underneath there that drained out about 600 years ago to form that feature. What we're seeing today is a much smaller version of that. We have a small crater collapsing. So there's a smaller magma chamber maybe under here perhaps that's been draining and collapsing, feeding the East Rift Zone eruption. But the size of the magma chamber is much bigger than that. Okay, and while we're on it, there've also been reports about how much magma has come out. People were saying something like only 1 or 2% of the magma has actually come out of the volcano, come out of the East Rift Zone eruption, given the subsidence, the collapse of the summit. And that's not that big a deal to me. I mean, everyone's concerned about the fact that there's maybe 98% missing still. But it's not all going to come out. I've mentioned this before. Not all the magma comes out of the volcano as well. One analogy that I like to make is when you have a bottle of soda or champagne, something like that, and you shake it up, and all the gas comes out, spewing the liquid out. That's how the eruption actually happens. It's a gas-driven eruption. So the gas is under pressure in the liquid, depressurizes, comes flowing out, bringing the liquid out with it as well. So when you imagine that champagne or soda bottle, if you shake it up, open a top, and just let it sit there and spew over, not all the soda or liquid is going to come out of the bottle. There's going to be quite a lot left in there. You might only lose the top quarter, or I haven't done it recently, so I don't quite remember. A quarter or a third of it at most, and it depends a lot on the liquid, how fluid it is, how viscous, how thick it is. So the lava's got different properties than the soda, of course. But just as a kind of first order example of how these things work, not all the liquid's going to come out of the volcano. Only the one carried by the gas is going to come out, and it's a very small percentage, even at best of times. All right, so don't worry so much about that 1-2% number. It's very interesting, of course, scientifically, but what people are reacting to is the fear that there's a lot more of it coming. There definitely is more coming, but it's not 98% more. That's the kind of the crux of what I'm trying to say here. All right, so let me go back to the map and kind of recap, because we've had some questions coming in. Let's go back to the eruption map. Okay, here it is. All right. So let's see, I'm working on questions from the bottom up. Okay, so how did lava get into Green Lake? Lava got into Green Lake from the surface. There were some reports that maybe the lava had heated up the groundwater and it was causing steam that way. I'm not sure at all about that. I wasn't there. That certainly could happen. But clearly, the more important development as lava came around the east edge of the crater and flowed in from the east side. It kind of wrapped around. There's a big gap in that crater over here, which maybe not everyone was aware of. So it didn't flow uphill over top of that thing. It went around the edge of it, and that's how it came in there. Will water come back into the lake? Probably not for a while. Maybe if there's a groundwater source right there, it'll be steaming for a while longer. But I'm just speculating at that point. I'm not really sure about that. Okay, so to kind of recap, we have fissure 8 right here as a dominant fissure. People have mentioned about how similar this is starting to look to Pu'u'o, building a big cinder cone, and that leads naturally to the question about whether this eruption will last as long as Pu'u'o has lasted. The thing to remember is that Pu'u'o developed over many, many years, right? So the first phase of Pu'u'o's eruption did have fountains that were actually quite a bit taller than this, reported about 1,800 feet high, maybe 500 meters. Whereas now we're talking about 300 to 400 feet high, maybe a quarter of that size, a fifth of that size at most. Okay, so eruption is beginning like Pu'u'o began, but that doesn't mean anything about how long this eruption will last. And in fact, there's a big difference so far, and the fountains are not shooting nearly as high as Pu'u'o. And one big reason for that is likely that we only had one, essentially nozzle, one place lava was shooting out from Pu'u'o, at least once it got established. And as you guys can see from this map, we have up to number 24, 25 on here already. So that's a big difference. If the pattern does continue of all the other fissures kind of shutting off and kind of focusing in one spot to number 8, then it is possible that we could start seeing higher and higher fountains of lava coming out from there. So that's something to certainly keep an eye on. I'm not sure if 9 will take away from that or relieve extra pressure. Maybe for some reason the lava is not able to get all the way under and come out over here in this edge as easily as it was before. I don't know why, but it's certainly possible that it'll back up and come out of number 9 over here, which has been reported to be steaming and degassing quite a bit more. All right, so that's kind of the update up here. Looking at this most recent USGS map, you do see some little red areas right here, here, and over here. These are areas that the flow is kind of spilling over its banks and breaching and kind of widening itself in the area for people in Nana Valley. Right now, it's still looking okay. I mean, the big danger is, like I mentioned in his last video, about the area of lava ponded in this area breaching and flowing to the north and kind of filling in this low spot, which is quickly disappearing, unfortunately. And once that happens, then the risk is a lot bigger for lava to come into this eastern part of Nana Valley, especially. All right, but for now, it looks okay. There's a little bit of lava expanding in this area over here, but there's still this ridge that's got to get over. That's not happening yet. It's happening slowly, but we haven't got to any kind of threshold anywhere near there yet. Most of the flow is going off in this direction, being fed to the east, all the way to here. So as bad as that is for beach lots and vacation land, Nana Valley is a beneficiary of that for now. Okay, so if anyone is in that area and they cut off down in here, there are going to be boats coming in and helicopters, I've heard, also coming into Pohoiki to take people out of there. So if you can see this and you're in an area and trying to figure out how to get out, that's how. All right. Okay, let me catch up back on my comments here. Okay, just 1 second. All right. So one more thing to mention about Nana Valley. The big thing is, of course, now you guys are downwind of all this gas and all this lava flow. So even if there's no flow coming directly to you guys, you're going to feel a lot more of the gases coming through there. So be prepared for that. If you're anywhere in the east of the Nana Valley, it's not a bad time to have all your plans in place. You know, have your stuff. You know, I hope it's all for naught, but you know, not a bad time to pack. Start packing things up. You know, get them ready to move if you have to move them, because as we've seen in this eruption so far, once that threshold is reached, things can change very quickly. So I'm not saying it's going to go there. I really hope it doesn't. But if it does go anywhere else next that we don't expect, that's going to be the likely place. All right. So no one panic, but it's all good for now. That's the area to start preparing. There's still plenty of time right now. People in Nana Valley, especially that eastern edge of it, right along this eastern steepest descent line, right through here. It's that easternmost, maybe 1 or 2 blocks that might be affected if the flow goes that direction, which there's no sign of happening so far, as all the lava is mostly going off in this direction over here. All right. Well, it's interesting. We have a kind of a flatter area up here where the flow was able to spread out, got a little bit wider, steeper, got narrower. flatter, it got wider again, and got really wide here in a flat. From what I've heard, it has not hit the ocean. I've heard it's maybe within a few hundred yards. I'm not sure exactly. So, but that's where it's going right now. The fact that we have such a narrow pathway right here is kind of like a funnel. It's a good thing. All the lava is being funneled down in this direction, and it's not spreading out up here in this area quite as much. So, for now, the area up around Papaya Farms, Noni Farms. I'm sorry, Noni Farms is over here. Papaya Farms is back over here. Noni Farms is looking for now like it's stabilized, although as we've seen, a lot of these levees, these big banks of lava can breach and spill over to either side. So Papaya Farms is farther up here. The lava flow is able to spread out in this area right here, but we have the big 1960 flow, which is kind of helping to kind of keep this thing to the south. It all depends how tall this flow gets, of course, right? If we're talking about these flows getting 40, 60 feet high, then suddenly these steepest descent lines, all this low topography matters a lot less. So that's kind of what we're seeing here, these big flows. The way that I think about flows is it depends a lot on how much gas is mixed into them, right? So the fact that the fountain is what's feeding these things, maybe a lot of the gas is maybe escaping from here and not having a chance to mix as well into the flow. And that's why we're having an flow instead of a Pohoihoi flow coming forth. And we're seeing this different dynamic of how the flow actually progresses and advances. So, okay, that's what's going on down here. Let me see. A couple of general points. It's been reported now that this flow has covered over 4,200 acres, right? Which is a huge area. Compared to 55, that's a lot more. 55 was only 3,900 acres. It lasted 3 times as long as we've had so far. So it's possible that the lava will spread and cover more areas, or it could just pile up the areas thicker. That's certainly possible. But it's also possible it could thicken the areas that it's flowed over already, right? It's also, in 1960, we have this purple area up here, pinkish purple area. That was just the area of the 1960 eruption just by itself. So historically, as far as what people have been around to see, well, let's put it differently. Since Western people have been around to see and actually measure and make maps of these things, this is one of the biggest areas impacted so far. Of course, the Hawaiians have been here for a lot longer than the Westerners, and they've seen much bigger flows than this, not only in Mauna Loa, but also in Kīlauea. So the thing is, we don't have exact maps and much detail and progression as we have for this eruption that's happening right now. So that's the deal with the area we've covered so far here. So kind of to recap, 8's the active one, 16 might be leaking a little bit down towards Kīlauea, but I would say not much to worry about there because this event seems to be dying off. If the flow from here increases a lot more, then it certainly could grab our attention again because that goes back down to towards the area that we're all concerned about down there. Okay, so, and then the next one potentially to come would be number 9. That's the one where we're seeing reports of extra steam, extra sulfur gas, extra heat. Temperatures in the cracks have also increased substantially, right? So, this area down here is all already under mandatory evacuation, but it's looking to be cut off fairly soon now. You know, the time has finally come that it should be time to cut off those emissions people are taking back into this area, potentially once this thing starts to steam and potential for lava to come out of it a lot more. All right, so let me recap now the Halemaumau area. So let's do a little more thorough, but the main getaway from what's happening at the caldera is the crater is still collapsing, still growing. This animated sequence here from May 5th up until a couple of days ago, showing how the crater began as a simple 12-acre little pit, growing larger to the north, to the east, and now most recently to the west. Big cracks happening over here. There's not much space for these things to fall all the way in, but they can certainly slump in and make a bigger crater, larger than 24 collapse crater that we saw, that we have an imprint of right there. Okay, so let's back up a little more and do a little more general. Let's see, main page. Okay, over here. All right, so here's our tilt plots of what's been happening at the volcano. We can see there's been another ash explosion coming out. Nothing huge, similar as a pattern as before. There's a lot of ash being deposited around the volcano area, all the way down to Pahala. Okay, so that's still going on. tilt for the rift zone that's reported here is kind of not as relevant anymore, since Pool O doesn't have magma coming out of it anymore. So this is something we can, at least for now, ignore. It'd be more useful to have something down at Leilani, for example, but that data is not public, at least not yet. So here's the past week at the summit. You can see the series of lots of small collapses and explosions, then bigger ones and bigger ones. The pattern is pretty steady happening there, and for the whole past month, we can see before the eruption actually began. Here it is, end of May. Lots of small explosions. The bigger ones have happening more recently here. All right, so okay, that's the plot for Kīlauea. I've seen some questions about Mauna Loa. I will get to that, I promise. But let's look at the earthquakes now in Kīlauea. So here's the earthquakes in Kīlauea. We can see this is the last day. It's all right around the summit area. Some on a rift and maybe just south of the rift on a flank as a flank is moving. That's the same as we've seen over the past maybe a whole week or so. So nothing new right there. Let's kind of zoom out a little bit and look at the pattern for the whole island. Okay, there it is. So this is going back now for the whole last month. The red ones being the most recent ones. The red ones are the ones we just looked at in the last image. Okay, so here's our summit, here's our rift zone, and the eruption site down in an area over here. Now let's look at Mauna Loa. Look at the lack of that pattern in Mauna Loa. There are some earthquakes around Mauna Loa, but not that many, not in any clear pattern. So we're not seeing signs of magma moving inside Mauna Loa, at least right now. Okay, at least not moving towards the surface. So it is full of magma. The whole volcano has been inflating. Maybe let's just jump to that right now. Okay, so let's see. All right, it's a couple of things to start. There is a whole web page, a whole series of tabs on a USGS website just for Mauna Loa. Okay, so Mauna Loa, they have their own webcams, their own tilt meters, their own GPS, all of that, their own updates put out as well. One thing I gotta keep in mind is that this is a very high point on a mountain. So we see the thermal image right now, it looks all red. It's, the sun is shining on the crater floor. And it's a really black, very well lit, unclouded crater floor right there. And so that's what that image is showing. So to really see what's going on, you're gonna have to look at this thing at night. And the cracks, the crack reportedly with a steam coming out of it, and maybe some gas, and definitely heat. It might just be an adjustment of Mauna Loa kind of to the movement of Kīlauea on the side of it. So we're definitely concerned about Mauna Loa, especially in the long term, because it has erupted a lot and it hasn't for a while. So that is going to happen also in our lifetimes. Okay, so that maybe is a topic for a whole other discussion. But for now, Mauna Loa does not show signs of erupting. It does show signs of moving. Yeah, that's not exactly the same thing. All right, so let's see what else we got in Mauna Loa. I can show you guys here. Okay, this is a plot that's 3 years old, 2.5 years old now, right? From 2015, when we saw something happening in Mauna Loa. So what will happen before an eruption in Mauna Loa is something like this. In this case, there was no lava that actually came out of the ground, but you can kind of see just on a very basic level, how many earthquakes occurring per week over each year, right? So, you know, a little bit, and then growing quite a lot in 2015 especially, right? And then also we have distances measured across the size of the crater, because the crater, when it gets full of lava, it kind of swells upwards, but also spreads outwards. So when we see the magma injecting into the volcano, that's what it's doing. So when we see these kind of signals, lots of earthquake happening around Mauna Loa, underneath it especially, when we see the ground moving apart from the sides at a much faster rate, because you see here it was actually moving apart also, it just got a lot faster. Okay, so when it starts moving faster, that'll be the time to get really concerned about Mauna Loa erupting. As just to recap, what happened in 2015 was not an eruption. It was kind of magma moving up further inside the volcano, but didn't actually come out of the ground. All right, so that's kind of what to look for and why we're not worried about Mauna Loa quite yet. All right, so it can be moving. You can see in the GPS right there, it can be moving, but it doesn't mean it's going to erupt anytime exactly like that. So here we go. Here's the tilt at Mauna Loa in the past week. We're basically seeing the signals of, I haven't correlated them exactly, but most likely these are explosions of Kīlauea that are kind of ringing through the ground. But overall, a very, very flat pattern, right? There's not a whole lot of movement of the ground in Mauna Loa, not like what we're seeing in Kīlauea, like I just showed you guys. All right, so for the past month, you can see a similar thing. The scale is also important. These explosions are really ringing the thing quite a lot. But overall, the pattern really is flat. All right, so it's not moving that much, at least in a last week, last month. Okay, so here are some GPS plots showing for the past year now. Okay, the past year was actually a slow rise in earthquakes of Mauna Loa. There was a big jump right here, January of this year, but it's kind of been more or less steady since then. Maybe it's more useful to look at the longer term pattern in the last 5 years, okay? So here's acceleration. We're talking about in 2015, it had us worried. This big increase in the slope, right? The sides of the volcano spreading apart, right? And also lifting up as magma came into them. When we see this, then we'll be worried. We don't see it yet, all right? So for now, Mauna Loa is all good, all right? So maybe it's useful to go back to Kīlauea, where's the Kīlauea page. Let's look at what Kīlauea's pattern has been. All right, so past 5 years of, oh, this is Pu'o'o, but you can see Pu'o'o had a couple of little episodes where it changed the direction of lava flow and cracks, and then the event this past month has been over here on the right. Whereas the same thing for Kīlauea Summit. All right, it's a little hard to see because the scale has been so dramatic with the dropping, but there's a little rise here to end, right? That was what preceded this eruption. That's why the USGS actually put out about a month before this eruption began. They put out a warning saying that they were seeing these signs of stress of the volcano swelling faster than normal. That's what kind of led to the high alert for Kīlauea, which we're now seeing was extremely warranted. So that's what the GPS tells us and why we're not worried about Mauna Loa imminently, at least. Now, long-term Mauna Loa does erupt, perhaps every, I think the number I remember is for the last 4,000 years or so, it's got about a 7-year average. You know, like volcanoes don't work on averages, they just go whenever they're ready. So that doesn't mean anything, but it helps us kind of understand the patterns of them and brace ourselves for eruption that certainly is going to come within our lifetimes. All right, so that's Mauna Loa. Okay, so let me just kind of read one more thing here, Mauna Loa. Let's go back to the, all right, so this is the Mauna Loa photo update page. Just to remind you guys, let's get up to the top here, all right? Mauna Loa has its own webcams, images, photos, monitoring, all right? So deformation data, the past week, month, all of that's all on the USGS website as well, okay? And if you go to the main homepage, whoops, that's not what I wanted. Here's the main homepage, right? We've been looking at the links from Kīlauea up here. That's where all data has been coming from up here. This section over here, Mauna Loa, that's where you get to that information on the USGS website, all right? So you can kind of keep an eye on that. Nothing changes very fast. As in Kīlauea, we saw the signs of swelling maybe a month ahead of time. Earthquakes happened about a week ahead of time. So that's kind of worst case, you know, of how long we'd have. And considering Mauna Loa is a bigger volcano and has more magma within it, those signals should actually be enhanced, we think. Maybe there might even be more lead time until that actually happens. All right, so that's the Mauna Loa update. Okay, so just to recap, Mauna Loa, we might see a new crack. Heat can come out, gas can come out. That's all great, but we're really waiting for those earthquakes, especially, and the GPS and tilt signals to show us that something more imminent is about to happen. All right, because as I've showed you guys, we've had failed eruptions in Mauna Loa before, or magma moving, and it doesn't mean it's coming out of the ground, even though we do get on high alert for those kind of things. Okay, so let's see. Maybe I can come back to my questions now, or let me see if there's anything on here that I haven't quite covered. What I had got pulled up for you guys to look at. All right. Okay. Well, yeah. There's one other thing over here, and that is the thermal map. Let me find it. There it is, the thermal map. All right, so this is already outdated, as everything has been a few hours after the fact. What we can see from this map is where fissure rate occurs down here. It's about to load, I hope. There it is. Feeding this big, massive lava flow that has had a branch, the Nana Valley branch, is kind of the weaker one. You can see most of the flow going to the east. It does kind of split right here into 2 or 3 different sections, the main flow being the southern one, carrying most of the heat. That fed that flow all the way to Kapoho Cone that has since spread out and covered an area more or less like that, right? And expected to hit the ocean shortly in this area right over here. All right. Okay, so that's the another interesting image to show. They didn't do any mapping in these areas down here, so we really can't know what's happening in the area here from this information. And just what's happening with the current imagery up here where they actually mapped. This is all done by hand, by the way. You know, the guy holds the camera and shoots it out of the helicopter while flying over the flow. So that's why it takes so long to do that and why I don't cover all the area. And just imagine how much work these guys are putting in to do this every couple of days in between everything else they're doing as well, right? Okay, so let's see. Let's see. I'm trying to read back the questions, but if I haven't answered the questions, feel free to type them in again, then I'll have a better chance to see them here at the bottom. All right, so let's see. Okay, both volcanoes at the same time. That's an interesting question. Mauna Loa and Kīlauea. So let's go back to this main map over here. Let's see how useful this actually can be for us. I'm not sure how much structure it shows on here. But okay, Kīlauea is basically this slice of the island over here on the right, at least at the surface. Mauna Loa is bigger and sits underneath Kīlauea as well, and it covers most of the island, kind of to here, all the way down here, all the way through there. Now these volcanoes have separate magmatic conduits. They have separate paths of lava from deep inside the earth to the surface of the earth. And those pathways are separate and they don't actually mix. We know this by looking at the chemistry of the lava itself. As the lava comes up through the rock that it's moving through, it picks up the traces of the rocks that it's moving through and actually incorporates them. And each lava has its own special chemical fingerprint, we like to call it. And we know that Kīlauea and Mauna Loa have distinct ones of those. Okay, so the magma from one is not going to push into the other one and erupt out the other side, or vice versa. They're all separate systems as far as magma plumbing is concerned. Now, Kīlauea does sit on top of Mauna Loa, right? And that is important in many different ways. You know, one is in fact of how Kīlauea can actually move. Kīlauea doesn't move to the north because Mauna Loa is too big and too heavy in a way that way. That's why the south flank moves and the Helena slump and all that discussion we've talked about. This area over here is so important is because all the movement of Kīlauea has to go that way. It can't go anywhere else, right? The last eruption of Mauna Loa was 1984, and it did erupt while Kīlauea was actually erupting as well. So this is an area of active research. People don't really know exactly what the connection is exactly as far as how the volcanoes affect each other. But we do know that one leans on the other. So let's say that Kīlauea moves towards the ocean, then suddenly Mauna Loa is not getting pushed by it quite as much. Maybe it can move towards the ocean a little bit as well. That could explain some cracks opening up. That could lead to an eruptive phase in the future, not immediately. These things take time, of course. At this point, it's just speculation. We don't know for sure, but there certainly is a possibility of that happening. It's not going to happen exactly, immediately, right away. But they do lean on each other in that manner. The other thing that's and that's basically it. Is how Kīlauea leans on Mauna Loa and it supports itself that way. Okay, so Mauna Loa puts out a lot more lava during its eruptions, typical eruptions, than Kīlauea has. So when Mauna Loa erupts, and we're a lot more worried about what's happening on the island, believe it or not. I think of Kīlauea like a teenage volcano. It's very young and energetic and going through a big growth spurt, but it's still only 4,000 feet above sea level. Mauna Loa is almost 14,000 feet above sea level, and it's been erupting for a long time. So the flows of Mauna Loa could actually reach all the way to North Kona over here. You guys know, familiar with the Waikoloa area by A Bay, there's a Mauna Loa lava flow from the 1800s in that area over here. The south section, that's very, very steep, is maybe one of the most concerning in Mauna Loa because the area, here, let me switch back to the map. All right, so Mauna Loa, Waikoloa is actually all the way over here. Mauna Loa flows from 1800 all the way up there. The south area over here is actually maybe the most concerned because it's got such steep flanks. The reports from the ships sailing by in the 1800s, the lava flow is reaching from the summit all the way to the southern coast. Whoops. Southern coast down here in as little as 3 or 4 hours. So because the ground is so slow, or so sloped, the lava flows can go a lot faster down in that area. So that's what we really worry about Mauna Loa, is that area down there. but something we've been talking about for a long time. Civil Defense has been working with the USGS and HVO for a long time to figure out how to make sure those people can get the most warning as quickly as possible when that actually does happen. Not if, but when. All right. So this is Mauna Loa down here. Mauna Loa actually is what Hilo is built on. The flow comes, the base of Mauna Loa comes north in this direction, all the way over here. There actually is a northeast rift zone that goes in this direction, actually all the way into Hilo, right? If you guys look at the Kīlauea hills above Hilo, those are cinder cones. Anywhere there's a cinder cone is somewhere a lava fountain was shooting into the air. So believe it or not, what we're seeing in Leilani today has happened in Hilo in the past as well. And so that's the Mauna Loa up this way, that way, kind of around this way, down over here. That's all Mauna Loa, wraps around Hualalai volcano as well. So Mauna Loa is the biggest one that we worry about. Okay. Let's see. Okay, here's something worth talking about, active volcanoes. All right, so the terms we use in geology for whether volcanoes are actually active are somewhat arbitrary. Generally speaking, a good rule of thumb is if volcanoes erupted in the last 10,000 years, then it's actually active. That might seem like a long time to people, but for a volcano, that's basically like taking a breath. The analogy I like to use is coming across a person who's lying unconscious on the ground. If you go to the person, you want to see if they're breathing or not. You typically got to wait at least a second, right? You can't sit there for a quarter second, half a second, say, oh, they're not breathing, and start panicking and declare the person dead. They haven't had enough time to go through the cycle of breathing in and out, so to speak, right? So you'd have to wait at least a second to assess whether a person lying on the ground was done breathing or not, right? So for volcanoes, that period of time, we've picked an arbitrary number of 10,000 years. So if a volcano erupted in the last 10,000 years, we call it active, okay? So a volcano can be active and erupting like Kīlauea, or active and dormant like Mauna Loa. 1984 is well within the 10,000 year range, okay? So other volcanoes on Hawaii Island. Okay, so 84 was the last eruption in Mauna Loa. Kīlauea is erupting now, of course. Hualalai last erupted in 1801. Okay, so very much within an active phase. Active and dormant, right? Last eruption in 1801. Mauna Kea's last eruption was 4,500 years ago. Also active and dormant. So we have active, dormant, active, dormant, active, dormant, active erupting. Okay, there's another volcano on this map. It's a little farther up. Kohala. That volcano we call extinct. Okay, now extinct is a little bit misleading and might lead you to believe it's never going to erupt again. It probably will, but for much different reasons. So basically the way the magma is no longer feeding into this area, right? It's basically sitting parked underground. But what happens now is that all the rain can start eroding, taking away all the rock from above that area and basically taking away the rocks that are holding in the magma. So if it rains and erodes fast enough, you can actually induce an eruption of an extinct volcano. And there are areas on, and, you know, the mechanism is more complicated than just that. You know, there are other things that happen. But you can see areas like Diamond Head on Oahu is much younger than the rest of Oahu, right? Diamond Head may be an area of a couple 100,000 years old, the rest of Oahu being a couple million years old. That's a big difference. Well, up to, you know, several million years old. So that's the difference between active and extinct volcanoes. Active and erupting, active and dormant, all right? So there are many active volcanoes, and Kīlauea is the one that's actively erupting right now. All right, so let's see, okay, volcanoes. Okay, volcanoes in general. We talk about two different kinds of volcanoes. The stratovolcanoes, like St. Helens, Pinatubo, Krakatau, Fuji. Most famous volcanoes in the world are of that variety, the stratovolcanoes. Sometimes also called composite volcanoes. Those volcanoes have magma that's much stickier, right? More viscous. It's got to do with the chemistry of what the magma is composed of. It's got more silica. It's got more silica within the magma itself. That makes it stickier, and in particular, the gases escaping from the magma are not able to escape as easily from stratovolcanoes as they are from the kind of lava we have here in Hawaii. So the gas pressure builds a lot bigger before an eruption. An eruption actually occurs because of an explosion of that gas pressure destroying top of the mountain that allows all the magma to decompress and come flowing out. So that's basically how that works. On Kīlauea, our magmas are more fluid. They're still very, very viscous, very thick compared to water, for example, but more fluid than the ones at St. Helens and those kind of stratovolcanoes. So when we have a lava lake at the surface and we see it bubbling, the lava just bubbling gases out and a constant steam plume flying from Halemaumau crater, that's a good example of how that's the case. The magma is not holding the gases inside, it just bubbles right out and flies away. That means the lava flows, when it comes out, is also able to kind of be much runnier and run a much longer distance downhill, as opposed to piling up steeper hills, steeper flanks of the mountain, because it's so sticky it can't flow very far. And that's kind of the root cause of the differences in these volcanoes and how they erupt, especially the stratovolcanoes from the shield volcanoes we have in Hawaii. Okay, so that's kind of big picture stuff. You know, within a small context of what happens in Hawaii itself, we have interactions at the water table. So we now know that the magma coming up through the water table underneath Kīlauea summit, it produces big explosions as well. The pressure is slightly different, but as far as the amounts of explosions, like how often they occur and like how much ash, powdered rock they leave behind, we've actually found that Kīlauea may explode more often in St. Helens in its recent past. So that's why the USGS rates Kīlauea as the most dangerous volcano in the US, because of its dual threat, both of explosive eruptions and what we're seeing today in the lava flows. And we're unfortunately seeing both those things at the same time right now. All right, so that's the big picture of different kinds of volcanoes. Okay, let's get back to what's happening in Hawaii. Let me get back to the map. Go back, here it is. All right, so we've heard Fissure 8 is breached and flowing north. I can't confirm that. I'm not in Hawaii right now. I can't tell you. You have to look at Ikaika's feed to see that. But it would not be unexpected, with as much lava is coming out here and ponding up as high as it's built, for these flows to start breaking out and flowing this direction over here. Downhill is still this direct, still that way, right? So anything overflowing from here is going to spill over and flow to the northeast again. And that's where it kind of fills in this low area. Well, it wasn't a low area before, but it is now. This little valley between this ridge to the north and a new flow to the south. And once that gets filled in, that's when we worry about the flow spreading out beyond the confines of Leilani, potentially further on. That hasn't happened yet, as far as I know. It's quite possible there's a breach of a fissure of the fissure channel in this area over here, but it should still fill in this low area and kind of work its way back in this direction over here. Okay, I don't expect it to do anything like that. It's more about how often does this actually happen? Once, twice. The more often it happens, the more likely it's going to fill in that whole area and then spill over to the next basin over. All right, so that's the most active event number 8. And just to recap, that's the one that's putting out almost all the lava right now. A little bit leaking from 16, but maybe tailing off. It's feeding a small flow that we haven't heard much about, but generally speaking, should not be as impactful as the one that's flowing north through Kapoho and presently through this residential area right in here. So it doesn't look like it looks like it's going to be a bad day as far as houses burning down, unfortunately. But that's what we need to be prepared for today. All right, so Fissure 9. Fissure 9 is steaming more, has gotten twice as hot, it's putting out more sulfur. All those signs indicate magma moving towards the surface again, right? There's already a pathway out. Magma came out of this fissure already. That's why I got named number 9. So it's quite possible, maybe even likely, it'll come out of the ground there again as well. The big question is going to be, does it put out as much lava as 8 does? Or is it going to be a small one like 16 has turned into more recently? Yeah, so, but certainly 9 is a big area of concern, and it could easily put out flows that fill more of Leilani, which hopefully by now is all evacuated and there's no one in there anymore. All right, so one last thought about Kīlauea and St. Helens. We talked about how Kīlauea, for different reasons, different mechanisms, different amount of material, can actually explode more frequently than St. Helens, right? It doesn't mean that it's the same kind of eruption at all. And unfortunately, most people, when they hear that sentence, they hear Kīlauea and St. Helens in the same sentence, and that's all they hear. They don't hear what the differences are. They don't hear what the similarities actually are. They just say, oh, it's just like St. Helens, which is not at all what I'm saying, right? I'm saying that it explodes for a different reason, but potentially those explosions can happen more frequently, right, and not be as impactful, right, as a St. Helens eruption, right, just to clarify that. All right, okay, let me go back over some questions. PGV, I don't know much about PGV. I'm not in Hawaii to hear about that. What I did hear is that lava had basically covered several of the wellheads. Several have not been covered as well. You can see on this map, most recent map, there's a little red margin. Lava is still flowing along the edge and is still kind of creeping up. It will likely kind of fill in more of this area around PGV. You can kind of see the cinder cone that's still remaining behind. There was a cinder cone within Leilani, right there. Oh, where is it? Right there. That now has become a little island surrounded by lava. So that could happen over here at PGV as well. We're just not sure. Not sure how this flow is going to spread out, how it's going to fill around, but certainly it's still under threat from lava covering the rest of what hasn't been covered yet. There's been some discussion. I don't know what the, like how. I'm not sure what the impacts really are, but there are some reports of H2S readings being picked up in Pahoa at the sensors over here in Pahoa. And if those are actually coming from PGV area, I have no idea. I know that the EPA is on site. I know that they actually just announced their fine for the previous unvented H2S event that happened in 2013 at PGV, so they're definitely keeping their eyes on those guys. There is some question about whether lava covers a well, whether it actually is going to immediately cause an explosion or slowly degas what's inside, or maybe there's a delay between when H2S comes out. We have also heard that the monitoring station at PGV has been burned down, right? So they're not monitoring their own stuff anymore. They were doing things by hand, I had heard. However, I would doubt that's still going on because of the access being cut off, right? Highway 132, which was the access in and out. They were coming in this way and then getting in through a back road. Now the highway is cut off over here as well, right? So now there's no way in to this piece of road, right? There would have been, but the other road has also been covered in this direction. So I don't think there's any on-site testing. I could be wrong about that, but I'd be surprised if there was still that going on, with the monitoring station essentially being in Pahoa, right? And we do know that right outside Pahoa, there has basically been an EPA van parked for most, roaming the area for most of the past at least a week or so. All right. Okay, so let's see. Highway 130. We haven't talked about 130 yet. So the cracks that happened on 130 have happened in an area down around here. Somewhere in here. Yeah, right in here. And in fact, there's actually been a new, just through here, there's been a new road built, connects this branch down off the map back to 130 around those cracks. Right, so that's a kind of short-term solution in case those cracks do widen, and maybe lava doesn't have to come out of them. But if the cracks get big enough, you can't drive across them anymore, right? That's the big concern there, is that you can have Kīlauea be cut off, not even by an eruption, but by just ground cracking, right? So that's kind of the concern for Kīlauea. The fissures would have to show signs of moving back uprift in this direction before any lava concern is present over here. So cracks and steam is certainly the first step of being concerned about it, but given everything else that's going on, I'm not worried about that imminently. I'm more worried about what's happening over here. If 9 opens up, and then 10, and 11, and 12, then we can talk about that more realistically, being a situation that actually could happen. All right, so, however, okay, so, but there's another hazard that we need to worry about as far as lava flowing south from there. Most of the flow now from Fissure 8 is actually going to the north, right, through this pathway up here. And we saw how much lava is feeding that big flow. So there's a possibility that as lava fills in this back area over here, it actually gets to this rise. There's another rise right here, right? These rises, by the way, are old eruptive centers of the rift zone. So this is another place that was active many years ago. But if the lava does breach that hill, then it can start flowing down towards Opihikau area, right? That's a danger that hasn't occurred yet. We hope it doesn't happen. But certainly if you live in this area down here, I would be very prepared for a short-term change to happen, and I hope it never does, but it could. Yeah. So, okay, one other thing about H2S I wanted to mention, you know, I'm not an expert as far as like how lethal H2S actually is, but what I do know is that concentration is an important thing, and the closer to the source you are, then the more likely you are to have a big concentration of it. So, to me, the biggest threat of exposure would have been for the workers at PGV itself, who are right near the well monitoring it. The farther it goes from that site, the more dispersed it gets by the wind, right? And the more diffuse it gets. So the concentrations are a lot lower, maybe more widespread, but lower, right? So the impact should decrease the more that that cloud of fume disperses from wherever it's coming from. Yeah, so yeah, H2S is dead. Sure, I see that, but you know, H2S is the smell of rotten eggs that we smell. We've all smelled that smell before and not died from it. So that, you know, just smelling it's not enough, right? It has to be in a big enough concentration to actually be lethal. So that's the big thing. All right, so here, I'm gonna come back to some other questions. I don't know about Kapoho Cemetery. Yeah, Fisher 8 and 9 area is the area around Moku. Moku Street's the one that goes just left of 9. Pomakai is the one right over here. Let's see. The fissures can crack open further, but we have to wait. You know, we're not going to guess on that actually happening. Let's see. All right, guys, I hear my kid crying, so I'm going to wrap this up pretty quick here. I'll do this again. Let me see if there's anything else that I can quite quickly address here. Let's see. All right, nothing's jumping out at me right now, but any last questions? Type them in right now. Okay. Yes, I do live in Hawaii. I'm not there right now. Pahoa would certainly detect lower concentrations than Navale and actually what's coming out of PGV, that's for sure. So I don't know what the concentration would be in those areas. Beach lots and vacation lands are going to get it today. I haven't heard exactly how far they've come, but the flow is in that direction and it's spreading out in a big area. So yeah, it looks terrible for those people today. The big half circle of Kapoho, this is an old cinder cone. There was an old eruption when magma came underneath here and actually met groundwater and caused a bunch of explosions. All that debris fell all around it. The trade winds come from the northeast, right, from this direction over here. So all the material falls to the southwest, and that's why we have that kind of horseshoe-shaped cone. All right, let's see, John. Yeah, thanks, John. Let me know anything you find out about the updates. And anyone else? Big earthquakes in Halemaumau, yeah, certainly. Now that the pathway of gas from Halemaumau is clogged, we can expect more frequent ash explosions. They're not going to be earthquakes so much, but the ground may shake. If you go on the website that I've been promoting, where is it? This one, earthquake.usgs.gov, right? That one actually shows a history of the earthquakes that have happened. You want to look at the sizes on the left, right? The depth, the closer to the surface, the more likely it was an explosion and not something happening deep underground. But if we go back far enough, we'll find one of these volcanic explosions actually marked on here. Let's see where there is one. Coming. There have been a lot of earthquakes, so let's see. No, it's not on there. Well, what you'd actually see is it would say volcanic explosion, and then it would say 4 kilometers, wherever it actually was. So that's going to happen. You can expect more of those to happen, more ash explosions as well. All right, guys, feel free to message me any questions you might have. The 2% of the flow from the crater, I addressed that earlier in the video, so go back and watch the beginning. Mauna Loa I talked about at the beginning as well, so go back and look at that as well. And anything else you guys have, yeah, add it to me in Messenger, and I'll get back to you guys as soon as I can. All right, guys, take care. Hui ho. And stay classy, Puna.